So now we'll finish your notes from your meters lesson. So we use the same formulas, but there's a couple differences when we look at our results for negative and positive and stuff like that. So when you have DO and DI results, they are positive for all real objects and images. That's still the same. DI is negative for all virtual images. The focal length is positive for real images and negative for virtual. So the focal length, again, is the variable that you would have to manually enter it in as negative or positive. The DO and the DI, yeah, you wouldn't have to. The negative focal length is for all convex mirrors, but for concave mirrors, the focal length is only negative when the object is in front, or when the object is in front of the focal length. So when we did this example, okay? So for these mirrors, for our concave mirrors, only when the object is in front of the focal length is your F, negative. So negative focal length for all for concave mirrors only when object is inside the focal length, or closer to the lens than the focal point. Okay. The HI is positive for upright images and negative for inverted. All right, so let's do an example. An object is 3 centimeters tall, so HO is 3 centimeters, and it's placed 10 centimeters, so distance, from the mirror. Oh, and we're given a concave mirror, and the object is placed, okay, so if we think about it, we're given a concave mirror. We're told that the object is 10 centimeters away, and it's 3 centimeters tall, and that the focal point, it says, or the focal length is 3 centimeters. Okay, so let's say about that. This is 10, and this was 3. So we know, since the object is not within the focal length of a concave mirror, that we can set our focal length to a positive value of 3 centimeters. Okay, and we're asked what is the height of the image. So HI is our question mark. So the formula that has HI in it, with the variables that we've been given, is as such, but we don't have DI. But we can find DI using our formula that has F in it. So this will be the second step we do. And the first step we do will be going 1 over, so number 1 is 1 over F is equal to 1 over DO plus 1 over DI. I'm just going to erase this to have a bit more space. So what are we looking for here? We need to find DI, okay? So we're going to rearrange to solve for DI for this step, so we can put it into step 2. Okay, so let's rearrange this formula to solve for DI. It's positive right now, so I'm going to leave it on this side of the equal sign. and I'm going to minus 1 over dO from this side and this side. So now I have 1 over F minus 1 over dO is equal to 1 over di. Okay, so let's put that in. So we have 1 over 3 centimeters minus 1 over 10 centimeters is equal to 1 over di. So take out your calculators, plug those fractions in, and yeah, our focal length stays as positive. So you should get 0.23 repeating, but that's in centimeters to the power of negative 1 is equal to 1 over di. So to solve for di, we go 1 divided by 0.23 repeating. So my di is equal to positive 4.2857 centimeters. Now I'm just noting the positive to say, okay, this positive, because that's our d, so it says dO and di are positive for all real objects and images. So since this was a resultant value that was positive, I know for sure that this is real because my image distance is positive. So now I can use that value for my second formula. So the second formula is hi over ho is equal to negative di over do. So now in this, it's negative there because that's how it actually is in your formula sheet. So I can put a positive value in there. So just leave that negative as it is because that's how it is on the formula. I'm going to rearrange to solve for hi. So if you cross multiply, that looks like a minus. Ho multiplied by negative di. So to rearrange, I have hi is equal to ho multiplied by negative di over do. So now I can plug in my values to solve for this. So my ho was 3 centimeters, and my di is right here, so that's a negative of a positive, so 4.28, etc. All divided by, excuse me, 10 centimeters. So my hi will equal negative 1.28571 centimeters. So a couple things to note here is that this means it's inverted. So if we look back at our notes, it says hi is positive for upright images and negative for inverted images. So we know this is inverted, which makes sense because when you have a concave mirror, which concave, it's like this one, where if you look into it, you're upside down. Okay, concave. Yeah. Okay, so then our final answer is hi is equal to 1.29 centimeters. Great. So, and its characteristics, if you were asked characteristics too, you would say that it's real, it's inverted. Oh, and also, we could put in magnification, but we could just look at what hi and what ho is. So ho was 3 centimeters, and we found hi was 1.2. So then we can also say it's smaller, because 1.2 is less than 3.0. So you don't have to put in magnification, only if you were asked how much was it magnified by.